All right, let's get this on the road. Obviously, DrForr, Jeff Goff. Yes, I am the one that broke the hip last year. All right. What we're going to be talking about here is Perl 6 grammars, regular expressions, and how to embed your own grammars into Perl 6. The latter area is still very much. Are we much closer? Okay. Much. Very resistant microphone. All right. To recap, we're going to talk about Perl 6 grammars, Perl 6 regular expressions, and how we embed those into Perl 6 again. The latter section is going to be more or less a show and tell. One of my more twisted, shall we say, modules. And the macro libraries that we need to do this properly are not yet ready. I need to talk with Mossack and a few other people to share ideas. But what I have right now is working code, and it passes all its tests, which is the important part. So, just to poll the audience here, how many of you are using Perl 6 right now? Okay, excellent. And you're all using regular expressions? Okay, at least a few. Okay, and in Perl 5, how many of you are using regular expressions? Okay, excellent. All right, one of the first criticisms that we tend to get in the Perl 6 community is that regular expressions have completely changed. This is somewhat true. Some of the more exotic options have changed as far as I am concerned, and as far as the compiler is concerned, for the better. So let's start out by looking at a good old-fashioned ISO timestamp. Believe it or not, we will get into languages later on in the talk. But as a refresher for how Perl 6 regular expressions work, let's start out with this. This is your good old-fashioned ISO 8601 timestamp. Very dense, no white space involved, and we have a, I forgot the time zone, and you got the, I must be at another talk. How to do matches have changed slightly in Perl 6. We now use the tilde operator instead of equals tilde. This, in my opinion, is a change for the better, because if you're using regular Perl 5 expressions to do a match and you have the equal sign, people tend to get confused. There's a little cognitive dissonance going on there. Why are you using an equal sign when you don't actually change anything in your match? Sure, you're reading something into another variable, but you're not actually changing you're not actually changing any data. So what we do in Perl 6 is get rid of the equal sign, stop confusing people, and use 2 equal signs. I don't have my laser pointer, unfortunately, has run out of charge, otherwise I'd be using that. Back to Perl 5 land, you'll see we still use these slash delimiters, slash or in slash, but there are a few changes that you have to make. Oh, yes, please. Looks like the one that I used yesterday. All right. Delimiters here and here are just as you do use in Perl 5. No changes. The one change, again, that's for the better, is how you deal with these characters. All of the colons and dots and slashes. How many of you have used character classes in Perl 5? Pretty much everyone. Okay. How many of you have written this phrase? One moment. this one. A phrase like this in Perl 5. Okay, a bunch of you. And you probably know what the error you're going to get is. Obviously, you're going to be looking at the $, and you're expecting a match, and m/n 5.020. That's not even in the text. What's going on here? Most of you know $close brace is a variable. These are almost totally abandoned in Perl 6 now. There are 3 punctuation variables left. So you no longer have, so $signs here are now completely legal and actually work correctly. It does come at a slight cost though, because you do need to escape anything that is non-alphanumeric or a meta character. And that's it. You don't have to worry about counting backslashes. You don't have to worry about, do I backslashes inside the slashes or inside regular expression? Why balances inside a parent expression? All you need to know is that if it's alphanumeric or a meta character, don't escape it. Everything else gets escaped. And that applies for Unicode in general. So let's do that. There's the result. Also, Perl 6. There's been recently in the press a lot of talk about how Swift and Rust and Go do their error messages. In Perl 5, you see we get just one lonely line of text here, and a opening brace, and then something, who knows, at the end. Very confusing. In Perl 6, error messages are multi-line, much more readable. And in fact, over here, this portion usually is colored green. I don't have that in my Vim syntax highlighting. But this portion is colored green, and that portion there is colored red for easier reading. And metaphorically, what happens is the compiler goes along, reads character by character by character, and then whoops, we have a problem. So you eject yourself from the string, metaphorically. And again, it's telling you exactly what the problem is. The meta character dash should be escaped, or must be quoted if you're matching literally. And of course, it can't find the final slash because it has lost its way. So you got just this error instead of being bombarded with a cavalcade of syntax errors, error after error after error, or cascade error. That is because of how Perl 6 now parses a single pass, and when the pass is done, the compiler was finished, no matter what. So let's fix that by using the backslash on anything that is not a alpha or a numeric. So we have a backslash on the dash, on that dash, colon, and the plus here for the time zone. Now, the next feature of Perl 6. How many of you have printed out, say, a hash reference or an array reference for the first time? Remember the first time you did that and got this hash parent 0x1239AF? Very helpful. Wonderful for debugging purposes. Not. In Perl 6, the mantra is everything is an object. So you would immediately think that whenever you print out an object, you're going to get a hash parent. No, you don't, thankfully. Because since everything is an object, everything has a parent all the way up to the root object mu. and those all have a stringify function. So any type of string, any type of object, you can print out as a string. If you build your own object, you need to either override the default or use that, and that does actually return the address. But for most of the common types, for your strings, for your objects, for your date times, for your matches, which is what this is. And the whole result here, from here down to here, returns a match. And you tell that it is a match all the way at the first character of your print statement. These odd-looking quotation marks over here. They are Japanese quotation marks and designed for use in situations where you have to read as Japanese people do, right to left and top to bottom. So if you were to use, say, American style quotation marks, you'd have a quotation mark here, and if you have string, you'd end quote with a close quote right there when the rest of your kanji is down here. So this is why they come with the hook on that side. This is how you tell that you have a match in Perl 6. Again, all you have to do is look at the first character. So you know then what the data type is. Perl 6 comes with the /x modifier already on. So we put in new lines here, anywhere we want. /x is built in. You can use comments out here. You can put in white space, tabs, whatever you like. As you see, comments on the far side. You can even use capture. You can even capture that way, just like you do in Perl 5. Parentheses, FRN. If you need to use the non-capture variants, by all you can use square brackets. But I find the old-fashioned parentheses still work for my needs. Now the next thing is, looking again, we're going to go deeper into this, and I promise we will get to the language portion eventually, but we do need to know a little bit about how the regular expressions work to start. We have, again, a match object being returned from this operator here, which returns, first of all, the text that you're matching over. Every entry in the match. These are all the equivalent of $1, $2, and $3 in Perl 5, because of course Perl 5 has $0 reserved for program name. Perl 6 gets rid of that, so all of your matches now start at 0. So in Perl 6, this is now $0, $1, $2. And as you see, our object, the entire match operator here, has returned a much larger array now. Now here is an array of index 0, index 1, and index 2. So you have a match object that returns a list of matches, or let's a list of match object, or you can still use the old-fashioned $0 to match our text. How many of you have used name captures in Perl 5? Okay, wow, I'm impressed. I didn't really read about them until very recently myself. So this is one way to do a name capture in Perl 6, because of course you can do things more than one way. This is generally not the way that I recommend doing it. I will show you reasons why as we build up to the finale. But this is documented and works. You'll see here we have the Pulp Fiction brackets, as it were, the angle brackets. Angle brackets in Perl 6 surround either bare words or a list of bare words. Anywhere in code, as long as you're in the Perl 6 language. is a consistent. It is consistent as opposed to having braces and paras and brackets all doing different things at different times for different languages. And they are now named. So we have beforehand, I have eliminated the original string up here in the output, just for clarity's sake. Going down in, we now have, instead of $0, we have $brace date. So we can now name captures inline easily and not have to worry about what syntax we use. Refactoring a little bit. Let's take the T out of time because it's not Parse expression. Time down here changes again. So now let's refactor this a little bit more. Beforehand we had these $date expressions that were capturing text, but we don't really want that in our main match. We want to be able to lift that out into something else that we can reuse later on. So what we'll do is for each of the phrases that we were using the $brace date, we put them into a regex, much like you would in Perl 5 with a QR. This is just a fancy QR block. QR now has a name instead of being assigned with scalar over here, and they are scoped. So you can use any modifier, any scope you want there. And we now have the curly brackets there. This again is a feature of Perl 6. Anything within curly brackets is code. In this case, it's code in another braid of the language, but it's still code. So in the single pass parsing, you can go through the string, open brace, aha, I know I'm in code. Close brace, I know I'm out code, whatever language that's in. So you don't have to worry about what a brace does, what a parenthesis does, what a bracket does, and what sort of sigil you have to use before you start. And again, luckily we haven't changed our output down here. It still looks as if you have a regular match. Of course, we can put everything back the way it was. Just have a date, time, and time zone reference inside string instead of having, if you've seen, say, the Perl 5 email parsing expression, which is one long line. I think it's roughly 48, 49 pages worth of regular expressions. This way we can factor everything out into little chunks. So you can factor this out into, say, a username. You can say my regex username equals my regex domain name equals, my regex date, my regex username brace, my regex domain brace, and factor out in that way. So I take the expression, break it apart. And again, we still have our object down here. We'll show you how to read that very shortly. We've been using literal characters here, 2016, 01, 29. But everyone knows that you want to match more than just January 29, 2016. It's not much use otherwise. So, again, you're all familiar with this from Perl 5. \d plus. I'm sure you've all seen this. You've all used this. In Perl 6 now, numbers cover the entire set of Unicode. So if you want to say, if you want to match an Arabic date, you can use the match an Arabic date, you match Arabic numbers here. If you want to say match a single time, it still works. No change necessary, which is especially important for those of us that have done a lot of time in the I-18N trenches. Alternation still works the same way that it does in Perl 5 with the pipe. So what we're going to do here is add on the ability to use Zulu time. That's the Z, aka Greenwich time. So now we have the time zone down here is changed back to Zulu. So now, how do we actually use these newfangled captures? Well, in Perl 6, there are only 3 punctuation variables left, and this is one of them. $/ is a simple mnemonic for the slashes in your expression. It works the same way with M/, it works the same way with embrace, S/, S brace, S open brace, S bracket. S $/ is how you view matches. So here we're going to look for the date element of the capture here. So we apply this string to this expression, date, matches against date, /d plus dash dot dot dot, etc. So now we have captured our date. But we can go one more level here, because regexes can also take other regexes, of course. So what we're going to do is factor out finally our ISO timestamp into a single regex. So now all of what we had here before is packed up into one neat little bundle. So whenever you want to match a ISO timestamp in your string, just drop that expression in. That's it. You get a match for the ISO A601 timestamp, and inside the ISO A601 object is a separate hash graph of date, time, and time zone. The last thing is we really kind of want to package this up. So in reality, what we've been looking at, regular expressions in Perl are actually parser expression grammars. So they have slightly different semantics to Perl 5 than you're used to. Specifically the fact that tokens like these chunks of characters without white space, Perl 6 will go through looking for the longest possible match for that string. So that's a slight change from Perl 5 semantics. But again, we have our expression now. We have our match expression. Everything is still packed up neatly into a nice little bundle. And the last change here is we've changed from regex here to the term rule. Rules in Perl 6, if you're familiar at all with how parsing and grammars work, a rule is simply a regular expression which doesn't care about white space at all. So now, if we wanted to, we have our ISO A601 timestamp. We have a rule now instead of a regular expression. So anything over here is fair game. We can go in and update, insert spaces between the timestamp, like so. It'll still match. Because this here is a rule, we can insert white space between our dashes, like so, and we'll still match. White space now becomes optional. So you don't have to go through and type all of those \S plus expressions. Question? Does white space turn up in the match? Yes. Actually, no. Sorry, all the way around. For rules it does not. For tokens it will. My fault. Okay. Now moving on to the next step. I did this for FOSDEM, which is a more generic crowd. So you all know about that. Tilde is now the way to do matches. And this is by a very deep design decision. Because the tilde operator here is also the same one that you use to concatenate strings. Just one of those, though. If you were to say, let's see here, how do I put this? The first character of the two-character operation here is the type of now the type of data that you want to return. So if you want to match two strings, you return a string match. If you want to do operations on an integer, you change that to plus to do a match on a number, which I don't know. I can't think of why you would need that. At least on a number. But if you have, say, a Boolean operation, or if you're doing or and arithmetic, then you have the tilde version, tilde at to do binary and, or tilde at to do string and, plus at to do binary and, caret at to do logical and. So it is all now consistent. Capturing has not changed. You still use pairs. You can name your captures with this syntax or refactor out into a real expression, like so. And you break up your expressions into little words using tokens or rules. So now we're going to move things. Now we're going to move things a little bit faster and get into an actual language. Now I could have used Forth. I could have used R here as an example, but I figure a lot of you are familiar with JavaScript. So what we're going to do is, in the next few minutes, is write a just-in-time compiler for JavaScript. And it's even more fun when you compile Perl 6 onto JavaScript and then compile JavaScript in JavaScript. So we'll start out with this statement here. Console.log sum is the string and JavaScript concatenation operator 32. Roughly in the Perl world, if we were to run the statement, we would expect to see on the terminal the phrase sum is space 32. If we were to run this as in our JavaScript window. But we're doing Perl here, so we want to run the statement in our Perl terminal. So what we want to do is have this eventually say sum is 32. So what we're going to walk through now is how to break down a string like this in little chunks into an actual compiled parsable language. It's not that bad. I've done it many times myself. But the principles here apply to any language. You can put anything into these in between these quotes and still tear it apart line by line, character by character, and learn what each piece is and map it onto your file and output. So let's start out by checking to make sure that this actually works. So we say that our target string matches our JavaScript expression, and we get back our target string and our JavaScript expression match. Fine so far. We create a compiler that doesn't do anything. Great. So let's move on a little bit. Get a little bit more flexible. Right now, if we were to actually do anything with that, it would only be able to match on that explicit text, because we have no fancy expressions or operators here, nothing fancy going on. All it can match is this exact text. Okay, but kind of useless. So let's dig in a little bit and change it so that this phrase down here could be anything we want, as it would be if you were writing, say, a compiler. So what we'll do here is a little factoring out and choose to refactor our string into a string expression. Now, this doesn't quite actually work because you'll see, of course, the question mark here. Just like in Perl 5, that makes the expression non-greedy. So it will look for the quote here and eat everything up to the end quote and give us our output down here as part of our string, as part of the nested match. So now we're a little bit more flexible. We can do a few more things. If you want to try to parse the phrase console.log quotes hello world quotes plus 32, it will work. Let's get a little bit more detailed here. And choose to factor out the integer down here. So we have a integer. Over here, we create a token for the integer. Just a small chunk of text. And it appears down here as part of the match. So now it's a little bit more flexible. We can say console.log quotes hello world quotes plus 0. We can't do minus signs yet. Minus signs, you have to do a little bit more work to decide how the expression is to be managed. So we're going to treat this as a unsigned integer. So let's see here. We'll write down here. So let's write the compiler portion now of our expression. We have the parser, which is this here, up to here, 4 lines. So now let's write our parser, our compiler, our just-in-time compiler, as it were, which is right here. We have our match on JS, which is this here, that matches that. The string here matches the secondary hash, like so. And we're going to do as JavaScript does. The plus sign here is concatenation in JavaScript. Because we're in Perl, we have to change that now. We use the tilde operator. Yes, dot has now been co-opted to do many other things. So tilde is now how you do concatenation, which again is a happy coincidence. You have the tilde here that does string operations. You have the tilde here, which also does string operations. This is not a coincidence. So down here we have our string, but we've got these quotes here in the way. So let's go through and capture those quotes like you do in Perl 5 with parentheses. So now we feed our string here through our match. Our match cascades down to string and int here. And we have down here we have now a just-in-time compiler for JavaScript. Again, in 4 lines. Well, 5 lines if you count the interpreter. Now, in order to lead into the last section, how we're going to embed this back into Perl 6, we need to kind of package this up into one neat little bundle. So we have tokens and rules, and those of you that have done compiler work know that tokens and rules are generally associated with grammars. Those of you that have used Lex and Yak and Bison will understand this term. So it should come as no real surprise here. Pardon? Oh, down here. I'm sorry. That is because it happens to be the 0th index of the string match. Because inside of that, this way we can safely ignore the quotes, because those aren't part of the string. At least they aren't part of the string we want to parse in Perl. They are part of the string back in JavaScript, but when we parse that into Perl, we don't care about the double quotes. In much the same way that in Perl 6, we don't have to worry about the Q, we don't have to worry about QQ, Q quote, Q brace, capital Q, Q colon. There are a lot of variants there. Let's do one last thing, and this is kind of the last major change from Perl 5 to Perl 6 REs, and that is the character class. It's optimized now for single pass parsing, because we can now, the compiler can now look at a literal character here, because it's token, the white space, because it's a token here, the white space now matters. And we look here, we see the pointing brackets. Just like in Perl 5, just like in the other expressions, this is a bare word, this is actually a bare word, but in the RE language. Again, if you want to read more about that in detail, look up the term braiding in Perl 6 docs. So what we see here is in Perl 5, if you want to match anything but a quotation mark, you would say open bracket, caret, quote. But the caret really isn't part of the character class. If you have it anywhere else in the character class, it becomes just a caret. So what's happened in Perl 6 is we moved the caret here outside and turned into a minus or plus. So you have the caret, so you have the expression. So you say expression, anything but the quote. And as a further benefit, you can chain these operations inside the same character class. So if you are dealing with, say, a internationalization situation where you want to match, say, anything up to the Chinese character set and anything beyond that. In Perl 5, you would have to go through and specify each individual character range, 0 through what is it? I used to know this on top of my head. 29D0 or thereabouts, and 3,000 up to 4,000. Skip 4,000 up to here, and so on. Have four or five different character ranges. Now in Perl 6, what you can do with this is I will modify the string temporarily. And match A through Z, capital A through capital Z, white space. Anything but not the quote. So if you have, say, a character range here, like so, assuming that the quotes were inside that range, which they're not, you will match this range minus the quote. So you can now so you now take multiple character ranges, subtract one range from another, add in new ranges, all within the same expression. Again, for those of us that have done our time on the internationalization firing line, this is a blessing. So, we have our tokens and our rules here, and we kind of want to pack those up so we can share them with the public. So, in Perl 6, we have classes. We also have grammars. We have classes that package up methods and subroutines. We have grammars that package up tokens and rules. One more change here is that we have a rule called top, which is the top of the parsing tree. So this is where you would, so this is the rule that you would essentially feed, if you were, as it were, the text for your JavaScript compiler in. You would feed your rule into that, and it will go through and parse out all of the console log statements, look for the string, parse that out, look for the integers, parse those out, and lo and behold, we have a method called parse on our grammar. We call that method on the grammar, and it does its internal work, creates the match object, and we can run say on that layer. Now, that's okay if you just want to ship out your parser to the world. Doesn't help much for the compiler part down here, where you generate the output. So what we want to do with that is package that up as well. So we have the grammar and a class or object in order to take the output from that grammar. So that's what we'll do. What happens is over here we have still the same statement where we are taking a console.log file. So now what we do is we create a class in Perl 6 where we have a method which happens to have the same name as the rule we're firing. And whenever our parser here encounters that rule, it calls that method. So what will happen here is it matches console log string plus int and tries to call a method on that. There is no string method, so it doesn't do anything. There is no int method, so it does nothing. It says, aha, there's a top, aha, there's a top method, so I'll call that. So what happens here is, as part of the very tiny refactoring change here, we add an action. So now what happens is when the parser is complete, it runs the action. And that is how you package up your parser and your compiler in Perl 6. And now I need to switch gears a little bit here. And what we're going to do now is dig into how we actually make this work in Perl 6 inside the language, instead of having your parser standalone as a separate file and your compilers as a separate file. We want to be able to just say parse JavaScript. To be able to drop a, say, JS brace into our code and have Perl 6 all of a sudden switch into JavaScript inside there. But we'll try it with a little bit smaller string. In this case, what we'll do, and I have to switch gears, Okay, now we pick back up a little bit. So this is a kind of extreme example of how to do embedding in Perl 6. Let's ignore that bit right down there and skip down to the very end. Now, normally in Perl 6, of course, you have your normal numbers. You have 1, 2, 3, 4, 5. You have your hexadecimal numbers, 0x12ff. You have your binary numbers, 0, 1, 0, 0, 0, 1, and of course octal. But that's kind of old school. What I thought we would do is go real old school and add in Roman numerals. So that's what the last portion is about, how we actually embed a new parser into Perl 6 at runtime, dynamically with no compilation, no other variables necessary. So we have our sub foo call here, which takes an integer and another integer. And by the way, that's another nice feature. Personally, I think of it as welcome to the 2000s. We finally have working subroutine and method signatures for Perl. Hallelujah. So we have our sub foo here with that takes two integer variables. And by the way as well, you'll notice I use $A and $B. How many of you have used sort in Perl 5? Okay, how many of you have been caught out by the problem of declaring a sort, a $A or $B after your sort statement? Okay, a few of you. That goes away in Perl 6. You can use pretty much any variable name you want, as long as it starts out with a Unicode alpha character, which includes things like the Greek letter alpha, just to confuse matters. So as part of this, we want to obviously make sure that Roman numerals in Perl 6 work the same way that they do in any other language. So we have 0r IV, 0r VI. IV, of course, being the equivalent of 4. VI being the equivalent of 6. We pass this into our sub foo, and Perl doesn't even bat an eye. It says, okay, we have our new Roman numerals, 0r IV. And by the way, for the record, I debated with myself for about 3 or 4 days, in between other things, whether I should go with just 1R0, 1R IV, or 0R IV, because of course Roman numerals don't use zeros. So I figured, okay, it fits in more with the Perl, it fits in more with the world of the 2000s as opposed to the native 2000s, to use 0R for the name here. And I someday will get around to creating 0B for Babylonian at some point. But as you see here, we have a $V, which is a regular variable, a regular value, which is now a Roman numeral. And by the way, those of you that know Unicode fairly well know that aside from the usual IV, VI, there is in fact a set of Unicode Roman numerals sitting up in the High Latin range, Latin 3 or thereabouts. I'm sorry, Latin Series A or thereabouts, which are actually which are composed Roman numerals. We have those too. So we have I, IV. And if you want to go really old school, it even has Roman numerals that I've only ever seen in Amsterdam. Oddly enough, go figure. On the Westerkerk Tower, they actually use these characters here to indicate the date of when it was erected back in 1667. So they use this character here, 1000, and then this character followed by C, followed by D, and then 67. Let's see, LXVI is on the Westerkerk Tower. So this is how to kick it really old school Unicode style. Use these, which also lets you go up to into the 100,000s. There is a notation that lets you go as high as you want, but I have not yet done that. That is the ability to add a overbar over your Roman numerals. So that will let you go into the quadrillions. But I figure that's a little bit too extreme. So let's take a little bit of, so to be fair, it's not quite completely clean. You do have to use the module, but that's it. Perl 6, we've adopted the convention that modules that go in and modify grammars like this one does are called slangs. So we have the Slang namespace reserved for those modules, and and this is out on modulesperl.org. And you want to take a look at the code later on. Creates Roman numerals, and by the way, we do both additive and subtractive. In earlier times, there was an urban myth that the reason you use IV for clock faces is that back in medieval times they couldn't fit I on there. That's not true. If you go to places like Bremen or any other more popular areas in the world, they use IV or I for the number 4. That's a urban legend. Just thought I'd clear that up. So of course you have test suites here. You gotta go through the test suites. Got to make sure this all works. So let's take just a very brief dip into the code here. Down here is the grammar, which we've been through already. We have a Perl 6 now has both, as Kurz mentioned in this talk, Perl 6 now has both classes and roles. We use a role here because a role is a chunk of a class, not a full class. So what we do here is we add in our Roman numeral. We give it a name. In the Perl 6 grammar, we have binint and octint for binary and octal. So of course we have now a Roman int. Later on, we have to use, of course, the same Perl array expressions that we have come to know, and love. To start out with the 0R and the character class here, representing IV and the 2 Unicode ranges here for the II through IV, and the far ones for up through the 10,000 range. So you've seen this already. The angle brackets, close square brace on that side. This is something that anyone can write after a little bit of experience with Perl 5. I'm sorry, Perl 6. This bit down here, well, let's not worry too much about this. What I did actually was steal this directly from someone else's grammar. But what this does is, like, we before created a grammar for our JavaScript and a set of actions class. We create a class for our, we create a class for, we create a role for we create a grammar that matches what we want, and we create a set of actions down here so that when the Roman int token fires down here, whenever that gets called, we call this method, which is back in our Perl code. So now what we've done is we have altered the fundamental Perl 6 grammar in roughly 100 lines or so of code. And most of that is the listing of all of the Roman ints and their equivalents. So in reality, this bit right here and that bit down there does all the hard work. So within roughly 30 lines, we have not only modified the Perl grammar, but we've extended it from data types back in the 1990s all the way back to the negative 1990s. And I'm coming up on the end. Do we have questions out there? Aside from why would I do this? Exactly. Because I can? Why, yes. Exactly. Aha. Hold on.
I can tell it's quite, like you say, it only takes a few lines of code in a sense to write new grammars like this now in Perl 6. So I'm just wondering if we can then just inline that back into Perl 5 so we can keep writing in Perl 5 and just use these tools that you guys are creating.
Well, actually, there's already an inline Perl 6 that you can use out there in Perl 5. So yes, you can actually use this and call back to Perl 5, and then call back to Perl 5, call into Perl 6 if you wish, and link models that way. Perl 6 also can do this the other way around and use the inline Perl 5 module. But unfortunately, we can't backpatch into Perl 5 grammar this way.
Do grammar conflicts like shift reduce and reduce reduce get flagged at compile time?
Another excellent question. Perl 6 grammars are not, in fact, the question was rephrased, do you get shift shift or shift reduce conflicts? You do not, actually, because, in fact, Perl 6 grammars, Perl expression grammars, if you look up on Wikipedia, look up the term Parser Expression grammars. They are not, what he's referring to here is the shift reduce conflicts that you get with a LALR look-ahead grammar. Perl 6 grammars are not that style. They are Parser Expressions, which is a relatively new style of parsing. It doesn't involve tables like building up a large table that you would with a YAC-based parser or an ANTLER-based parser. So it's not table-based. So that's why you don't get those conflicts. So, paraphrased, Perl 6 Perl expressions aren't your father's YAC, if you will. You don't have to shave that yak. All right. Anyone else? Aha, one more.
Well, following up on your question, of course you would get problems if you write your grammar in such a way that it would really match things that are already in the grammar. And it may or may not take precedence, so you might get unexpected results because of that. Right?
Yeah. To rephrase and get back a frame here, the question was, how will you go? Do you get? Can you get conflicts if you try to write a parser to parse something that Perl 6 already parses? The answer depends upon how you modify the grammar. What I do here is I add my Roman int to the grammar right around here. Basically, this creates a new bar operation when you encounter the Roman int. But what you can also do there is override the internal grammar. And thus, when you encounter that, it will call your grammar instead of being conflicted. Okay, and I believe I have to wrap up here. Anything else? All right, thank you very much.